Let's see next question. In triangle ABC, prove that sine of b minus c upon 2 is equal to b minus c upon a into cos of a by 2. Now here in this question, if we look at left side, then it has all the angles, but on the right side we have the side terms as well as the angle terms. So therefore we decide to start off with right hand side and simplify it to the left side. So let us write the right hand side as b minus c upon a into cos of a by 2. Now we can replace b, c and a with the terms k sine b, k sine c and k sine a, as we have seen in the sine rule. So we can use the k method, which is what we call cos of a by 2. Now taking k common and cancelling out from numerator and denominator, we are left with sin b minus sin c upon sin a into cos of a by 2. Now if we look at the left side, we have to achieve the term sin of b minus c by 2, and we can recognize that this term appears in the factorization formulae, right? So if we look at the expression sin b minus sin c, it is clear that if we factorize this expression, we will definitely get the term sin of b minus c by 2. So therefore on factorizing we get 2 cos b plus c upon 2 into sin b minus c upon 2 into cos of a by 2 whole divided by. Now if you observe, we have already got the term sin of b minus c by 2, which is the left side anyways. So it means all the other terms must cancel each other, right? So at this stage we see that the angles in the numerator are all half angles, right? We see all divided by 2 everywhere. But in the denominator we still have sin of a, right? So that means it gives us an indirect hint that we have to convert a into a by 2 in the denominator also. So we can write sin a as 2 sin a by 2 into cos of a by 2. So we see that now, see the 2 gets cancelled, cos of a by 2 gets cancelled, and we know that in a triangle cos of b by 2 is equal to sin of a by 2, right? So cos of b plus c upon 2 is equal to sin of a by 2. So these two terms will also get cancelled. So therefore we are left with sin of b minus c upon 2, which is nothing but the LHS. So that completes the proof, right? Let's go ahead to another variety of the question. Now here in triangle ABC we have to prove that a cube sin b minus c plus b cube sin c minus a plus c cube sin a minus b equal to 0. Now here we observe that all the terms are kind of cyclically arranged with respect to each other. So like if we change a to b, b to c and c to a, we can rotate all the terms among themselves. So in this type of question, we don't actually solve the entire LHS, but what we do is we take a single term in it and simplify to the extent that we can easily generalize the simplification for the remaining 2 terms also, which helps us to find out the answer that they all cancel each other and give us 0, right? So let us start by taking only one term. So we say that consider the first term, that is a cube sin of b minus c. So putting a as k sin a, we get k cube sin cube a into sin of b minus c. Now here what happens is, if we keep a as it is, then that cannot be linked with b minus c directly. So therefore what do we do is, first of all let us break the sin cube as sin square a into sin a into sin of b minus c, and somehow we have to write this sin a in some different manner, and that we can do by writing sine A as sine of B plus C. Correct? That's a property of triangle. Into sine of B minus C. Now what do we do is we write each of the last two terms in their respective half angle results. So sine of B plus C can be written as 2 sine B plus C by 2 into cos of B plus C by 2 multiplied by sine B minus C can be written as 2 sine B minus C by 2 into cos of B minus C by 2. Right. Now what we are going to do is we are going to club different terms. Okay. So let us first write the first terms as they are, that is k cube sine square A. But the next brackets we are going to club in a specific manner, that is, let us take 2, then sine of B plus C by 2 and cos of B minus C by 2, right? So let us club these two terms, that is 2 sine B plus C by 2 into cos of B minus C by 2 in the first bracket. Now in the second bracket we are going to club the remaining 2 cos of B plus C by 2 and sine of B minus C by 2. So that is 2 cos of B plus C by 2 into sine of B minus C by 2. So that further gives us k cube sine square A as it is into first bracket. If you observe the first bracket shown here in yellow, it is nothing but the factorization of sine B plus sine C, and the second bracket is nothing but the factorization of sine B minus sine C. So therefore what we have got by multiplying the two brackets as k cube sine square A, we can club the two brackets as sine square B minus sine square C. Alright, now here what do we do is we can replace back the sine A, sine B and sine C in terms of the sides. So that means here we had taken A upon sine A is equal to k, correct? So therefore sine A can be replaced as A upon k, right? So therefore we can write k cube into sine square A will be nothing but A square upon k square to bracket, sine square B is B square upon k square minus C square upon k square, right? So therefore on simplifying, k square will get cancelled with k cube leaving 1k, but that k will get cancelled from the denominator k square leaving 1k and A square into bracket B square minus C square. Now this is where we have now arrived. Now if we look at the other two terms, we can say that the other two terms can be similarly simplified. What we did for the first term, the same can be done for the other two terms, and the second term can be written as 1 upon k b square into bracket c square minus a square, right? This is the second term, and the third term, that is c cube into sine of a minus b, can be similarly simplified as 1 upon k into c square into bracket a square minus b square. Now if you add up all these terms, everything will get cancelled and finally we will get 0. So therefore in this way we prove the given statement. So the idea was considering the cyclic nature of the terms involved, we take a single term first, simplify it to the extent that we can do the similar simplification for the other two terms, so that the terms can easily get cancelled and hence they will result into 0.